Hi everybody, it's Saltash Maths Tutor, and today we are going to be covering standard form to GCSE and I suppose higher GCSE type papers. But what we need to note for all of this wonderful stuff, because standard form is relatively easy, but there's bits in the toolkit, and that's what we're going to look at. And if we know these bits, then it makes all standard form questions really easily. Firstly, we have to understand the format of standard form. We need to have a tiny look, and it's only a tiny look everybody, at power rules. We also understand and need to understand how a decimal place works, and then we're going to look at adding or subtracting, dividing or timesing, or in fact we're going to look at converting numbers, all to do with standard form. Okay, so standard form, the first thing is, what does it look like? Well, it's a number, and that number can only be between 1 and 9 times 10, and that's always to a power. So an example of that would be if we had something like 4, because that's a single number between 1 and 9, times 10 squared. That would be an example. Or we could have, and I'm trying to get my eraser here everybody, we could have 8 times 10 to the 4. That would be another example. Sometimes we could have something like 5 times 10 to the, and then we get a minus number, and we'll talk about what that means later on, but we can have a minus number up there as well. Another little thing is that we can have, if you like, bigger numbers here, and bigger numbers in terms of we could have 3.2 times 10 to the, pick any power you like, to the 4th power, or we could have 3.27 times 10 to the 4. As long as we have a single number here, we're allowed to do that, and then we can have a decimal place anything we like after that. And so that is the standard form. Okay, power rules. Power rules that we need to take note of are, and firstly we're going to look at this one here, is that x to the power of a times x to the power of b equals x times a to the b, and all that means is that, and I'll keep it in tens because we're going to be dealing with tens, if I have 10 squared times 10 to the power of 5, I add the 2 and the 5 together and I get 10 to the power of 7. Dividing, here's the general formula if you like, x to the power of a divided by x to the power of b equals x to the a minus b. Sounds horrible, it is when you say it like that, but then we've got 10 to the power of 7 divided by 10 to the power of 3, and all that means is that I have 7 take away 3, so it becomes 10 to the power of 4. Okay, let's just talk about decimal places. 6 times 10, well, I guess intuitively, mathematically, we know it's going to be 60. Just because we're doing standard form and the movement of the decimal place is quite important, another way of looking at that is to say, well, 6 is 6 decimal 0, and what do I do when I times 10? Well, I move the decimal place 1 right. When I multiply by 10, I move it right 1, which means that I end up with 60. How about 6 times 10 times 10? And I'm writing it like this for a sort of a reason, I guess. Well, we know that 6 times 10 is 60, and if I times it by, let's just get rid of that. If I times that by 10, I get 600. Whoops! I get 600. And the reason I've written this like this is because, well, another way of looking at that is that that is 6 times 10 squared, and hey, we're already in standard form, aren't we? That's what standard form is, the single number, the 10 and a power. But one of the key things is to pull out is that whatever the power is here is the number of noughts, or the number of decimal places that I move to generate the new number. So we had 6 decimal 0. I'm going to add another 0 on so I know what the answer is going to be, just for the point of illustration. And to times it by 10, I move the decimal place 2 times to the right. Now we'll look at divide. 6 divide by 10. Well, intuitively we know it's 0.6, but it's sort of the opposite. It's the undoing of multiply. I could look at it in terms of I've got my 6 decimal 0, because that is 6, and what do I do when I divide? Well, I move it, the decimal place, 1 to the left. So I end up with 0.6. And again, if I have 6 divided by 10 divided by 10, in other words, as we saw before, divided by 100, or if we wanted to write it so divided by 10 squared, it's the same argument as we had here, then that will be, we'll start with our 6 decimal 0, and then I move it once, twice, there's nothing to go there, and the decimal place goes there, so it's 0.06. So we just need to be aware of multiplying and dividing by 10 moves the number, the decimal place rather, left or right. So, as quite often can be the place, the easiest way to look at all of these things brought together is with examples. So what we're going to do is we're going to write the number 1,440,000 in standard form. So what do we need to do? Well, we open our toolkit of standard form, and from our toolkit we pull out the fact that we have to have a number times 10 to some sort of power. P for power, like what I've done there, people. But we also know that this although it can be a number like 4 or 5 or 6, it can also be a decimal like 3.5 or 3.56 or 3.57, or however we want it to be, and that's going to come in fairly handy. So I can just look at this number here and just see where I can get that number plus any amount of decimals afterwards that I want it to be. So let's write the number out as 1440 000, and where's that going to be? Well, I can have a play around if you like. If I put the decimal here, does that work? No, because that's 14, which is greater than 9, so that doesn't work. I could put it there. That's 144, that's even worse, I don't want that. So does that satisfy what I want? Yes, there's a single number there and there's a whole load of decimals after it, so that's fine. So that, the first bit is done. I've placed the decimal place properly. Now I have to ask myself the question, if I had this number here, what would I need to multiply it by to get that number there? And I'm saying multiply because I know, going back to the previous example, that 6 times 10 gives me 60. It adds a naught on. Well, I want to, or, and this is the better way of looking at it, it takes 6 decimal 0 and it moves the decimal place 1 right to give me the bigger number. How many times do I have to move the decimal place, and which way do I need to move it? Well, I need to move it, and I'm just going to change colour here. I need to move it once, twice, 3, 4, 5, 6 times. And I know from what I said before that that gives me 10 to the power of 6. That is 6 noughts that I have to add on after the decimal place. And I also know that my number, because I can drop these noughts now, is 1.44 times 10 to the power of 6. Now if I wanted to test that, and testing is always a great thing, I can undo what I've just done and see if I come up with the right answer. So I'll take my 1.44, and I know I want a bigger number. I'm going to multiply by 10, so I'm just going to add some random noughts in here, and I've literally just chucked in 5, see how it goes, and I'm going to multiply it by 10 to the power of 6. So I'm going to move the decimal place 6 places right. 1, 2, 3, 4, 5, 6. And so the decimal place now goes there, which gives me 1, 4, 4, 0, 1, 4, 4, 0, 1, 2, 3, 1, 2, 3, and that is the same number as that. So I've got it right. Quite often, everybody, just to let you know, in your exam, you'll very often, the first standard form question is actually this type of correction. I say correction, changing a big number into standard form, or vice versa. And we've sort of done an example of both of those there. So one more example of how to correct a number, and this one, it's write 7,900 in standard form. Well, here's the standard form up here, 8 times 10 to some power, and we know that the number here has got to be a single digit, but it can have some decimals afterwards. So I'm just going to look at 7,900. I can sort of disregarding the zeros, I'm left with 79, and I know that the number's got to be something like a single number and a decimal. I'm going to try it here. Yeah, that works. 7.9. So that, I think, satisfies my number out the front. It's a single digit and it's got some decimals afterwards. That's all good. Now, what have I had to do? What do I have to do if I had 7.9 to turn it into 7,900? Well, I'd have to take my decimal place and I'd have to move it once, twice, 3 times to the right, which is the same as multiply by 10. How many times have I moved it to the right? It's 3. And I can do that checking thing. Let's take 7.9, which is what I think it is. I'm just going to add some random noughts on the back end there, and I'm going to multiply by I'm going to move the decimal place by 3. 1, 2, 3. What do I end up with? Yep, I end up with 7,900. So this is the correct answer. So, third example of correcting things or changing them to what they want to. You're given 6.4 times 10 to the 4, which is in standard form already, and you're asked to write it as an ordinary number. And all that means is just undo the standard form. So, I'm going to take my 6.4, I'm going to add some noughts on the end, and then I'm going to do what it says. And what it says is multiply by 10 to the 4. It's not a brilliant 4 there. Let's put a 4 in there like that to the 4. So multiplying by 10 to the 4, which means move the decimal place 4 right. 1, 2, 3, 4. And my new decimal place is going to be there. And that gives me 64,000. 64000. Happy? I hope you are. Okay, so now we'll look at standard form and addition, and there are quite often lots of ways of doing this, and one of the easiest ways is sometimes just to convert it into an ordinary number and then do an adding process. There's another technique which I'll show you with this this particular type of question that I've got up here, but the first thing is let's convert this one here. So that is 3.21 times 10 to the 3. Now I'm going to do it reasonably quickly because the previous slides explained how to do this, but that's going to be 3,210 because I've taken 3.21 and multiplied it, and there's the 3 decimal places moving because of the power in there. So that's that. Let's take a point out, and then 2.47 times 10 to the 2. Well, I'm going to move the decimal places to right because that's what it tells me to do there, and that gives me 247. Then I add those up, 7, 5, 4 and 3, and then I convert back into standard form. And so I know that I can't have anything but a single number and digits, so I pick 3, decimal 457, and that's times 10 to the power of, what do I have to do to turn 3.457 into 3457? Well, I need to move it 3, 1, 2, 3, right, so that's to that power there, cubed. But there is another way of doing this, which is, instead of having to do all that conversion thing, I don't have to do the conversion, but it does need a slight manipulation. But here's the thought behind it. This is an idea that we're going to take into this problem, which is this. If I have 2 times 10 squared, which is in standard form, which is 2 times 100, I know that that is 200. If I add 2 times 10 squared, which I know is another 100, then I get 200. That's exactly the same as saying that if I add 2 and 2, I get 4 times, and I've got the same number to the same power. All I do is just bring it down, because I know that 10 squared here is 100. 100 times 4 is 400. Neat trick, eh? But the key thing is that the powers, as long as they're the same, then I can do straight addition there. So that's the idea. So applying that idea to this problem, what I want to do is, I've noticed that here and here I've got 10 to the power 3 and 10 to the power 2, and I need to make some sort of conversion. So I'm going to convert this first, and I want to make that into 10 to the power of 3. Now if I increase the power here, I have to decrease by a power of 10 on this side. In other words, if I had 2.7 times 10 to the 2, that would give me 247, because I've moved the decimal place twice. But I want to move it 3 times, so what would the standard form be then? Well, not that, if you like, not the standard form, but sort of. Well, the decimal point will be there, because then I'd move it 1, 2, 3, and still end up with 247. So in other words, if I multiply by 1 power here, then I must divide by a power of 10 here, which gives me 0.247 times 10 to the 3. Can you see that the numbers are sort of the same? The 2 here would move it that way twice, the 3 here would move it 3 times, but we'd always end up with 247. I think you either get this method or you don't, and also you can fall back on the previous method of just working it out if needs be, but I thought I'd show you this. Now that I've converted this one, I can just literally add 3.21 times 10 to the power 3, just like we did when we had the 2 times 10 squared thing going on. And I'm going to put a convenient naught in there, so I know it's going to be 10 to the power 3, 7, 5, 4, decimal 3. I've just added those two numbers together. And I'm hoping you've seen that addition, well, this so easily could have been a negative number in here, so we've sort of covered subtracting as well. It's the same technique. Either turn it into an ordinary number and do it, or you can do this manipulation of the powers and keep it in standard form. So next we will look at standard form and multiplying, and we're going to look at this, which is 2 times 10 to the power 7 times 8 times 10 to the 2. Well, the one thing that you can do straight away, if you wish to, is drop the brackets, so it becomes 2 times 10 to the 7 times 8 times 10 squared. And the great thing about multiplication is it, in this particular instance, doesn't matter about which way you multiply. So what I mean by that is this simple routine. Firstly, I multiply the numbers, and I get 2 times 8, which is 16. Multiply, because I've got to keep it in standard form, 10, and up here I've put the rule for you. So it's 10 to the, well, it's x, which is 7 in this case, plus my y, which is 2. I just add them, that's all I do. So it becomes 16 times 10 to the 9. Easy or what? So I'll give one more example of multiplication standard form. We've got this problem here, and again I'm not even going to bother dropping the brackets. In this case I'm just going to go straight into it, and I'm going to multiply 6 by 2, which is going to give, sorry, 6 by 2, 3 by 2, which gives me 6. I'm getting ahead of myself. Multiply by 10, because I'm going to keep it in standard form, and then I just need to do these two bits here, which I know from here is going to be 6 plus minus 2. 6 plus and minus 2 gives me, so it's going to be 6 times 10. 6 plus minus 2 is 4, and that's what the answer is. Really, really easy. Don't need to get stressed out about this, just need to follow the format of it, and that's it. Okay, and now we're going to have a look at some divide problems. So we'll look at 4 times 10 to the power 6 divided by 2 times 10 to the power of 3, and again, just like I did in the multiply, I'm going to go straight into it and look at the whole numbers first. Let's get my super duper highlighter thing up. Numbers first. So 4 divided by 2 is 2, and keeping it in standard form, it's going to be 10, and then using my rules that I've got in here, which I've copied over from a previous slide for you, power divided by a power is the power minus the power, so that's going to be that power 6 minus 3, so it's going to be 6 minus 3, which equals 2 times 10 to the 3. Cool. And we'll do one more of those, which is going to be, let's have a look at 4.8 times 10 to the 6 divided by 1.2 times 10 to the power of 3. Again, we're not sweating about this. We're going to do the 4.8 divided by 1.2, which, when you think about it, is the same as 48 divided by 12, which is 4. Keeping it in standard form, there's going to be a 10 there, and now I've just got to do my power, take away my power, so that's 6 minus 3, which is 10 times 10 to the 3. Easy? Yeah. And that, my fine friends, is it. A fairly swift counter through all of the sort of bits that you need to do. I will do another video on this, which is just going to have exam questions up directly from the papers and work through them, but I think it's probably a good grounding. Long old video, lots to say, technique in there, but it should give you a fantastic grounding for standard form. This has been Saltash Maths Tutor. Thank you very much for watching.